Hello students, welcome back to the classroom point. In our today's class, we are going to discuss about the discovery of the electrons, protons and neutrons and along with their properties. So let's begin the class now. Discovery of electron using the discharge tube experiment. So let's have the description about the discharge tube first of all. So this discharge tube contains a long glass tube which has the one exit point. This exit point is connected to the vacuum pump. The purpose of connecting this one to the vacuum pump is to adjust the gas pressure present inside of the discharge tube. And this discharge tube is having the two metal rods at both of its ends. The metal rod which is connected to the negative end of the battery is known as the cathode, and the metal rod connected to the positive end of the battery is known as the anode. And here the battery must be able to provide the high voltage of the current approximately 10,000 volts. Now, when the gas is at the normal pressure in the discharge tube, and whenever this high voltage of current is applied across the electrodes, no particles are generated because the gas at the normal pressure is non-conducting. Hence, whatever the cathode rays are there, they will not be generated at the normal pressure of the gas. Then, to observe the generation of the cathode rays, the gas pressure has to be reduced to as low as 10 power minus 2 to 10 power minus 4 millimeters of mercury. So when gas pressure is reduced to this much low pressure, and when high voltage current is applied, then we can observe the stream of particles are generated at the cathode. And here you must remember that whenever the particles are generated at the cathode, imagine this is the cathode, and particles are coming like this. We know that this cathode is in contact with the gas that is filled in the discharge tube. Whenever these particles hit the gas, they produce the light. Some fluorescence effect they produce, so that light starts glowing. The color of the light, whatever the color is there, the color of the light that generated during this process depend on the nature of the gas taken in the discharge tube. When type of the gas changes, automatically color of the light also changes. And next one, here when cathode rays or the negative particles when hit the gas, as they produce the light, so that this gas completely starts glowing. This glow is in contact with this cathode surface, and when current starts flowing by applying the high voltage, this glow, whatever the glow is developed, this glow starts moving away from the cathode surface. That means it detaches from the cathode surface, providing the vacuum or the dark space in this area. That dark space is known as the Crookes dark space. It looks like as if you ignite the gas stove. Initially, the light or the flame is in contact with the surface of that one, and whenever the gas content increases, then it starts moving away from the surface and providing the little dark space where it seems like the flame is not in touch with the surface of that flame area. So here also it looks like that. Now, these cathode rays, as I discussed, some stream of particles generated at the cathode, and they start moving towards the anode. Since the particles are generated at the cathode, so these are known as the cathode rays. And since these particles are moving towards the anode, so these are known as the negative rays or negatrons, later named as the electrons. These electrons are the negative charged particles, always travel in the straight lines. So the propagation or the movement of these cathode rays do not depend upon the position or angle of the anode placed. Whatever the position or angle it may be, they always travel in the straight line. And these cathode rays, since how to observe these are moving in the straight line means, if you try to put any object, sharp object in its path. It provides its dark space or image with sharp edges that shows that these particles are moving in the straight lines. And apart from that, if you put any pinwheel, these particles start rotating this pinwheel, showing that these are the particles having the momentum and they are having the energy or else energetic particles. And whenever any metal is placed in the path of the negative rays, these metals slowly get hit by these cathode rays and they acquire the negative charge. Afterwards, this metal start releasing the X-rays. And these cathode rays, let us see other properties of the cathode rays. These cathode rays, they are traveling towards the anode. Then how to confirm whether they are traveling towards the anode or not? Simply we have to put the holes on the anode. Then this anode is known as the perforated anode. Afterwards, you try to place one zinc sulfide screen which has the fluorescence nature. So when energetic particles or the charged particles hit the zinc sulfide screen, it produces tiny flashes. It confirms that the particles are coming towards the anode. And here, as we said that the particles are generated by the generated at the cathode, and here this cathode generation, this particle generation do not depend upon the nature of the gas taken in the discharge tube or else type of the materials used for the that means electrodes. The reason here is actually the cathode rays are not given by this one, only coming through the cathode, not from this metal rod. Why? Because the electrons actually comes from the battery. So whatever the electrons we have taken, considering those electrons are coming from the battery and they are passing through the cathode, that's why then the generation of the cathode rays do not depend upon the nature of the metal used for the electrode or else the type of the gas taken in the discharge tube. And these cathode rays are deflected by applying the electric field or magnetic field. Let us see how these are deflected by the electric field or magnetic field. That means if you apply the electric field or magnetic field perpendicular to each other, they deviated from their path. That means, as we said, that they are moving in the straight lines. So they don't go in the straight lines when you apply the fields. Let us see that in the charge to mass ratio of the electrons in this one experiment. This is the cathode, that is what we used here, and this is the anode, perforated anode, and here this is the zinc sulfide screen. So cathode rays are passing in a straight line. When electric field is applied, they hit the screen at a point A. When magnetic field means perpendicular to like this. Electric field is applied like in this direction and magnetic field is applied. One is perpendicular to each other. When magnetic field is applied, they hit the screen at a point C. When no field is applied or both fields are applied to the same extent, then they hit the screen at a point B. When no field is applied, that we can understand that field is not present. But when both the fields are applied to the same extent, same magnitude, then each field get cancelled and finally they hit the screen at a point B, and means they are moving in the straight lines. Then when electric field is applied, why the particles are hitting at the point A means, we know that the charged particles, these negative particles, cathode rays are carrying the negative charge. That negative charge get interacted with the positive charge. So they get attracted towards the electric field, positive charge electric field, and they are deviating from their path and hitting the screen at point A. And when magnetic field is applied, they are coming toward the point B. That shows that they are having some mass. Now here is the extent of deviation. When no field is applied, the particles has to hit the screen at a point B. But how much deviation they are going from the B point depend upon the three conditions. That is magnitude of charge on the particle, second one mass of the particle, third one is field strength. When charge on the particle increases, then automatically attraction by the electric field also increases, so that they deviate more. And when mass of the particle decreases, lighter particles deviates more, heavier particles deviates less. When mass of the particle decreases, then their deviation increases. Field strength, when either electric field or magnetic field, when we apply the larger field, more field is applied, more will be the interaction, then automatically deviation also increases. So let us take the three dots here. Imagine this is A dash, this is A double dash. 3 points are there now. So using these 3 points, we can measure both charge on particle and mass of the particle. When charge of the particle increases, deviation increases. That means when the particle is here, its charge is less, charge increased, charge still increases. That means when charge on the particle increases, they start moving away from each other, so that charge on the particle is more at A double dash greater than A dash. Field strength, even when field strength is applied, the same type of the order, we can see that when field strength increase, attraction also increase, again deviation increase. So here higher field, lesser field, even less field here. So field strength also same order, A dash, A double dash, A dash. Then what about the mass of the particle? Mass of the particle is measured using the magnetic field. So higher the mass of the particle, less the deviation, and lighter the particle, more will be the deviation. So now let us see here. C dash, C double dash. So here C dash, in the sense, here mass of the particle is heavy, that's why deviation from the point B is less. C means mass of the particle decreases. C double dash means the mass of the particle still decreases. Less the mass, more the deviation. So mass of the particle C double dash less than C dash. So J.J. Thomson carefully observed the extent of deviation from the point B when applied by the electric field. So this gives the information about the charge, but not exact charge, only deviation we get it. And by applying the magnetic field alone, he was able to calculate the mass difference here, the particles. So this deviation gives the mass of the particle. So by taking the careful measurements, he was able to calculate the charge to mass ratio of the electron as 1.758820 into 10 power 11 coulombs per kg. And what other factors we can learn from this one? Charge to mass ratio of the electron again is independent on the nature of the gas taken in the discharge tube as well as the material used for the electrodes. Whatever the gas it may be, charge to mass ratio of the electron remains always constant. And here again we have to come back to the point. At the speed of the electrons, as we said that the electrons are moving, or the cathode rays are moving from the cathode to the anode in the straight lines, but with how much speed they are traveling means they travel to the 1/10 of the speed of the light. What happens if gas is not present in the discharge tube? See, the cathode rays are generated only when the gas is present at the low pressure. Either at a higher pressure or no gas is present, no cathode rays are generated. Means if you create vacuum conditions here, cathode rays cannot be generated. And these cathode rays are highly energetic particles and they hit whenever the gas is present here, they hit the gas and they ionize the gas as well, and they create the heating effect also. That shows that they are the highly energetic particles. Now coming to the again charge to mass ratio of the electron. Using this charge to mass ratio and Millikan experiment, we shall be able to calculate the mass of the electron. Let us see that how to calculate that. Millikan oil drop experiment. So Millikan was able to calculate the charge of the electron using his oil drop experiment as Q equals to formula N into E. Here he calculated the charge of the electron as minus 1.6 into 10 power minus 19 coulombs. Where N is an integer value, it could be 1, 2, 3, 4, anything. So if N is equals to 1, N value, let us take Q value, Q equals to N into E. If N equals to 1 means this Q into NE value equals to minus 1.6 into 10 power minus 19 coulombs. If N equals to 2, that means 2 into E. So you have to do 2 into minus 1.6 into 10 power minus 19 coulombs. So this value is equals to minus 3.2 into 10 power minus 19 coulombs. If N equals to 3 means 3 value, minus 1.6 into 10 power minus 19 coulombs, that equals to minus 4.8 into 10 power minus 19 coulombs, and so on it comes. So the values always will be in this ratio only. So whenever you divide these values, you will get the exact this N value. That means number of electrons present in this case. So using the charge to mass ratio of the electron and the charge on the electron, so we can able to calculate the mass of the electron. So mass of the electron is equals to charge by charge to mass ratio of the electron. Here charge of the electron, see charge value cancel out and mass value will come out because this contains both the charge and mass values. So charge value is charge of the electron equals to 1.6 into 10 power minus 19 coulombs divided by charge to mass ratio equals to 1.75 into 758820 into 10 power 11 coulombs per kg. And here we can get one more information, that is about the negative charge, negative symbol. This negative symbol in the electron charge designates that it is having the opposite charge to the protons. Protons and electrons both are having the same magnitude of the charge. It shows only the attraction between the nucleus and the electron. This negative symbol cannot be used while doing the calculations. That's why here we have not taken any minus symbol. So these values after cancellation we get mass of the electron as 9.108 into 10 power minus 31 kg is the mass of the electron. Now let us see how they were able to calculate the or measure the protons as well. So let us see here. Protons also identified in the same discharge tube experiment. So Goldstein observed that when negative particles are generated, to keep the matter neutral, automatically opposite particles must exist. So that he thought he created the fluorescent screen behind the cathode. So here he made some holes on the cathode, making the perforated cathode. So here whenever these negative charged particles, electrons, hit the gas present in the discharge tube, as we said earlier, they have the nature of ionization. That means whenever they hit the gas, for example, if you take the hydrogen hit by the electron giving H plus 2 electrons. If you take helium hit by the electron giving He plus 2 electrons. If you take the sodium vapor hit by the electron, sodium ion in gas state plus 2 electrons. So whenever these cathode rays hit the gas in the present in the discharge tube, they ionize the gas, means they remove the electrons in the gas and they create the positive ions. So these positive ions are attracted towards the cathode and their propagation is observed by placing the zinc sulfide screen. Whenever the charged particles hit the zinc sulfide screen, they produce the tiny flashes. Whenever they are coming through these holes, they hit the zinc sulfide screen and produce the tiny flashes. So all these are now ionized gas particles. That means positive ions are created after hitting the this cathode rays hit the electrons are coming out this side. So like this, electrons are coming out, but these positive ions are moving in the opposite direction. These positive ions are not generated at the anode. That's why we cannot call this one as the anode rays. Earlier we called this one as the cathode rays because they are coming through the cathode, even though not given by the cathode, but coming through the cathode. That's why they were called the cathode rays. But these anode rays are not generated at the anode. They are generated in the mid of the path. Means from the tube, whatever the gas is placed in the tube, so within the tube they are generated. It looks like a canal. Canal means when river is flowing in the middle of the one, how the water is present. The same way here also, in the middle of the tube it is generated. Since these are generated at the middle of the tube, these are known as the canal rays. So these canal rays are the later named as the protons. So these protons are moving towards the cathode and hit the zinc sulfide screen and giving the again tiny flashes that shows that they are the positive charged particles. And what are the properties of canal rays and cathode rays? Already cathode rays properties we discussed. In the case of the canal rays, they also travel in the straight line. But the speed of the canal rays is less than the speed of the electrons. Because these are the canal rays are heavier particles, their charge was given as plus 1.6 into 10 power minus 19 coulombs. Means both electrons and protons are having the same quantity of the same magnitude of the charge but with opposite sign. And these canal rays also deviated by applying the electric and magnetic field, just like how the electrons were done in the charge to mass ratio calculation. But here the charge to mass ratio of the canal rays is less than the charge to mass ratio of the electrons. Why? Because in the charge to mass ratio, charge quantity is same for both electrons and protons, but mass of the protons is little bit heavier than the mass of the electrons. So that is the reason why both speed and charge to mass ratio of the cathode protons is less than the electrons. Now here, when protons are used in this tube, means modified, you change the cathode and anode, if you use it, then the behavior of the protons is exactly opposite to the cathode rays. Earlier, when electric field is applied, the cathode rays hit the screen at point A, but if you use the protons, they hit the screen at point C. Why? Because they are attracted by this negative field, not the positive side. Negative side they come. Now, discovery of neutrons. So Chadwick used the one experiment that he bombarded the beryllium sheet with alpha particles. Alpha means helium nucleus. Then he observed some chargeless but mass particles are generated. See, 4 plus 2 equals to 6. 6 means carbon. So 9 plus 4 means 13. So that only 12 comes here. Another mass is coming out here, that is neutron having no charge. Only mass is there. Similarly, when beryllium boron sheet hit by the alpha particles, then he was able to calculate find out the neutrons. See, these neutrons are the particles without charge but mass are there. The mass of the neutrons is a little bit heavier than the mass of the protons. Let's see the properties of the particles. Electron, proton, neutron. Their symbol is electron is E, proton is P, neutron is N. Absolute charge minus 1.6022 into 10 power minus 19 coulombs, whereas for protons it is plus 1.6022 into 10 power minus 19 coulombs. Neutrons are chargeless particles. Relative charge. we don't use the relative charge in doing any calculations. We take only absolute values. Relative charge, if you take this one as a -1, then obviously the protons is +1 and here it is 0. Now let us take the mass. Mass is equals to 9.108 into 10 power minus 31 kg, whereas for protons it is 1.672 into 10 power minus 27 kg, 1.674 into 10 power minus 27 kg for neutrons. In atomic mass units or unified mass, the mass of the electron to be taken as 0.000548 atomic mass units, whereas for the proton 1.00727 and this is 1.00867. And the symbol of the electron, proton and neutron like this, but here we can get the one more information that the symbol of the electrons, proton and neutron, we can get the some more information here. That is, electron has the relative charge of -1. Mass of the electron to be considered almost negligible. So electrons are called as the massless particles. So its mass is equals to 0. Whereas proton is +1. It has the some mass approximately 1. Whereas neutron's charge is 0 and it has the some mass that is 1 approximately. That means electrons are the particles have no mass but charge. Neutrons are the particles with no charge but mass. Protons are the particles with both mass and charge. Now when you compare the mass of these particles, mass of electron is less than the mass of the proton, mass of the proton is less than the mass of the neutron, and if you relate the mass of the proton and electron, mass of the electron is equals to mass of the proton divided by 1837. Means mass of the proton is 1837 times the mass of the electron. That is the reason why mass of the electron can be considered as the negligible mass. Now if you compare the charge to mass ratio of these particles, here whenever the charge to mass ratio of the electron is independent on the type of the material used for the electrode and as well as the gas, nature of the gas taken, but it depends on the voltage. When higher voltage is applied, the velocity of the electrons increase. When velocity of the electrons increase, according to the theory of relativity, the mass of the electron also increase. When mass increase, automatically charge to mass ratio of the electron gradually decrease. So charge to mass ratio of these particles decreases when their velocity increases. Now let us see the So let us see comparison of charge to mass ratio of particles. So let us take electron, proton, neutron and alpha particle charge to mass ratio values. First of all, let us take the charge value. Charge of every particle, let us take it is 1, proton 1, neutron is 0, alpha particle is +2 charge. So symbol not necessary to take, only values we are taking. Mass of the particle. See, we know that mass of the electron is 1 upon 1837 times the mass of the proton, and mass of the proton is 1. Mass of the proton and neutron approximately equal, and alpha particle is equals to 4. Alpha particle is nothing but the helium nucleus 2He4. So when you calculate the charge to mass ratio of these particles, 1 upon 1 again 1837, that means it gives 1837. This comes to the numerator finally. Here it is 1 by 1 giving 1. Here 0 by 1 gives the 0. Here 2 by 4 gives the 0.5. Then charge to mass ratio of which particle is the highest? Electron. So charge to mass ratio of the electron is greater than the charge to mass ratio of the proton, greater than the charge to mass ratio of the alpha particle, greater than the charge to mass ratio of the neutron, which is 0. The other information that we can gather from these calculations is radius of electron is equals to 2.8 into 10 power minus 18 centimeters, and radius of the proton is equals to 10 power approximately 10 power minus 13 centimeters, and half-life period of the proton is equals 10 power 31 years. So like this we can identify the nature and properties of the electrons, protons and neutrons and their calculations. I hope you understand this class. Thank you for watching.